So welcome to today's class. And today, of course, we're gonna continue pointers. We will have several weeks about pointers. And then the final topic of this semester will be string. And then actually we will just start the final exam. Okay, so the final exam will be at the week 15. And this week is week 12. So after 3 weeks, we will have a final exam. Okay. So Tia and I already start preparing the quiz for the final exam, the programming question. And I will say, just to make sure you understand all the programming exercise you practice doing programming lab. And then if you have any question you don't know, you didn't solve during the midterm exam, I strongly recommend you to try to solve them by yourself, okay? So if you still remember some of the questions during the midterm exam. Yeah, so that's the two things I want to share with you guys. And the other thing is that we will have our 专题展 this Friday, and I will encourage you to attend the exhibitions because you will see what kind of things you need to do to graduate, for the bachelor projects, and I think that's a really good opportunity to learn. Yeah, so that's the two things I want to share with you, and three things. Okay, so let's start with today's topic, that is pointers. And again, I always like to use some slides to check if you guys understand what we taught in last lesson. So I have 3 or 4, I believe it's 4 Slido quiz to test whether you understand the pointer arithmetics and how to use pointers as the argument for the function code. So this is the first questions. So the question is, what is the output of this program? So in this program, we have one array, ARR, and we have one integer pointer variable, PTR, and you point to one element in the array. And then we use the pointer arithmetics by adding 2 to the pointer variable, PTR, and then we apply the indirection operator. And then we want to print out something. So what is the output? Let's wait until we have 40 submissions. Okay, so let's check out the results. Very good, so around 80% of the submission choose the correct answer. So if you choose 30, maybe you forgot the AR1 is 20, not 10, because 10 is ARR 0. And if PTRs point to 20 at the beginning, if we add 2 to it, it will be 1, 2. So PTR plus 2 will point to 40, this element. Okay, so let's check out the next question. So next question is, again, another pointer arithmetic, and you need to choose the correct output of this program. And here we have 2 pointer variable point to the same array values. And during the pointer arithmetics, we talk about if 2 pointers variables point to the same array, we can subtract them, and the outcome will be something. So the definition of something is the answer to this question. And let's wait until we have 40 submission as well. And please feel free to check out the slide, the last slide, if you totally forgot the concept of pointer arithmetics. Because one of the purpose of these questions, this Slido quiz, is also to let you identify that you know what parts you don't know. Okay, so it's very important to know what you don't know so that you know what to learn. Okay, very good. We have 42, so let's check out the result. So the output is 3. So let me quickly explain it because I noticed there are still a lot of submissions choose the incorrect answer. So if two pointer variables point to the same array, we can subtract one from another. And the outcome of this subtraction will be the distance between these two pointer variables. And the distance is counted by the number of elements in the array. So basically, you just subtract the index number here, because P1 point to the value 1, P2 point to value 4. So if we subtract P1 from P2, will be 4 minus 1. That is the index number of the elements P1 and P2 point to. So the outcome will be 3. So you can see that if P1 point to 1 again, but P2 point to 0, 1, 2, 3, 4, point to 3. So 1 minus 3 will be 2. So there are 2 elements in between them. Okay, so this is another pointer arithmetics. Then, here is a more complicated program we have. And this quiz is to test if you remember how to use pointer variable as parameters and arguments for a function. So in this program, we have 3 printf. The first printf is inside the adjust and check function. So the first question is to ask you think about what is the correct output for the first printf. The printf inside the adjust and check function. You might want to take some time to read the statement inside main function. So again, we have an array data, and then we have another pointer variable, current PTR, current pointer, and this pointer variable point to data 0. And then we pass these pointer variables to the adjust and check function. And inside the adjust and check function, we use another pointer variable p to get the value of current PTR. And then we add 2 to p and then update the value of p. So, and we want to print out the star p. The star here is an indirection operator. Again, let's wait until we have 40 submissions. And if you already submit your answer, you can think about what is the output for the second printf and the third printf. What is the value? The second and the third printf are inside the main function. Okay, we're at 42 submissions, so let's check out the result. Very good. So over 80% of the submission choose the correct one. So the output is P is 30. So let's check out why. So because P have the, so let's check out from the, the first line of the main. So let's check out from main. So in main we have adjust and check, right? And we pass current PTR to it. And the value stored inside the current PTR is the address of data 0. So we copy this value and then assign to P. Because P is also a pointer variable, so it can store the address of variable. So now we make P also point to data 0. And then we use pointer arithmetics by adding 2 to P. So we move P originally point by 10. We move 2 elements to the right. So it's 1, 2, so it's 30. And then we just print out where P is pointing to. So that is why the result is 30. Okay, so let's check out the next one. So in the next one, you need to answer what is the correct output for 2, the second printf. And please don't forget, in the adjust and check function, we have final lines, we have final statement here. We assign a new value to where P is pointing to. Again, let's wait until we have, I think this is harder, but I believe you guys can reach 40 submissions. So again, let's wait until we have 40 submissions. And if you already submit your answer, maybe you can think about the output for the final printf. Okay, we need 2 more. 2 more. Come on. Okay, great. Oh, okay. So the correct output is this. We need to change the value from 30 to 5. And I also noticed a lot of people still choose this option here. So maybe let me just quickly explain it. And some of you choose this option here. So I can probably understand why you choose those 2 incorrect answer. So if you choose this one, data is 5, 20, 30, 40, 50, maybe you forgot that we already moved where P is pointing to. So originally, P is pointing to data 0, right? But here we add 2 to P, and we assign this value back to P. So by doing this, we move where P is pointing to. So the latest position that P is pointing to is 30, right? So that is why the answer of this question, this printf, is 30. And what this statement will do is to assign 5 to where P is pointing to right now. So P is pointing to this element of data. So we just assign 5 to here. So the value will become 5 instead of 30. So if you choose this one, maybe you forgot to move where P is pointing to, or you forgot that we update the value of P. And if you choose this one, maybe you forgot that we can change the data of a variable through the pointer point to it. So we successfully make P point to data, this array. So we can change the value of data by changing where P is pointing to. We can access the object through the pointer point to the object. So finally, let's check out the final quiz. So what is the final Slido quiz want to ask is, what is the correct output for the third printf? So the third printf want to print out the value stored in the object that current PTR is point to. So what is the object that current PTR point to? And let's wait until we have, again, 40 submissions. Okay, so let's check out the result. Oh, interesting. So actually the correct answer is 10 instead of 5. So, but again, this is a trick one, okay? So please don't worry if you get it wrong, because I kind of want you guys to get it wrong, okay? But if you get it right, that means you have a really clear understanding about pointers. So why this is the correct answer? So we need to know current PTR is pointing to data 0, right? So it's 10. And although we use current PTR as the argument, but we still need to remember the value stored inside the current PTR is the address of the object it points to, right? And inside the function, we didn't change. We cannot change the value of arguments itself, okay? What we change, because the value stored inside P is the address of data 0. So what we can change is the object P points to, but P is not point to current PTR. So the value stored inside the current PTR is not changed. So that is why current PTR is still point to data 0. And the value stored in the, data 0 is 10. So that is why the correct answer is 10 instead of 5. Because 5 is where P is point to, not the current PTR's point to. And the reason why P can point to 5 is that we move the position P point to inside the functions, but we didn't change the value stored inside current PTR. So that is the thing. So it means that you really need to have a really clear understanding about all the relationship between all these pointer variables and the variables and the array. So I will say you can try to draw the image figure by yourself and understand their relationship. So you will have a better understanding about why this is the correct answer. Okay, so that is all the Slido for you to recap. And I will say you guys did a really good job because most of you choose the correct answer except for the final one. But I believe you guys now understand why the correct answer for the final one is current PTR is 10. So that means that you guys are prepared for the thing we're gonna introduce today. So today, what we're gonna do is to introduce more things about pointers and array. And the next thing I want to introduce is an important fact that in C, the name of array is actually a pointer to the array. So we'll introduce these two topics in today's course. So first, let's check out more things about how to apply pointers on array. So in the previous course, we can see that pointer arithmetic can help us to visit the elements of an array using pointers, right? If we have a pointer variables point to the array, we can add or subtract value from the pointer variable so that the pointer variable can move around in the array. So that is why we can write down something like this. So what this what this program want to do is that we want to have an array A, and then we want to sum the value of the elements in the array A. So we want to sum all the value in the element of array A. And instead of using code the index one by one, I want to use a pointer variable P to traverse the array, to visit each element in array and get the value inside each element and add it back to the variable sum. So we can write down the function, write down a for loop like this. And let's check out the following slide to know what happened inside this for loop. So first, we can see that in the first expression of for loops, we make P point to A, 0. So let's assume this is the A we have, this is the pointer variable P, and this is the sum variable. So when we make P point to A, 0, P point to here. And then inside the for loop body, we first using the interaction operator to get the value of the object P is pointing to. So the object P is pointing to is 11. So we can get the 11. So here what we have is 11. And then we just add 11 to the original value of sum and then update the value of sum. So that is why the current value stored inside the sum is 11. And then after we finish the first iteration, we need to go back here, right? We need to increment P. So P will now point to A1. And then we have the second expression here to check if P reach the final element or not. Because the final element is here, right? It's n minus 1 is A9. And then we get the address of, we get the pointer, we get the address of A9. And because the pointer arithmetic, if two pointers point to the same array, we can use this relational operator to compare them. So if P haven't reached the final element, P will be smaller than this pointer to A9. So we start the second iteration. So for the second iteration, P is point to A1, and then we add the value of A1 back to sum. So this is the latest value of sum, 11 plus 34 is 55. And we just continue this loop. So the third iteration will be P point to A2, the next element. And we add the value of this element back to sum. So the latest value of sum is like this. So you can imagine that when this for loop goes on, the P will start from A0, A1, A2 until it reach A9. So this is one way of how to use pointer variable traverse a one-dimensional integer array. And then the next thing I want to introduce is that when we use this kind of array, there are some, I would say, handy expressions. So this expression can help us to write down a more concise code. So to learn this handy expression, the first thing we need to learn is how to combine the interactions and the increment operator. So for the most of the time, we will combine these two operators when we want to use pointers to traverse an array. And we can see the example here. In this example, we show the statements that modify an array element first, and then advance, and then move to the next element. So let's see. So here, again, we have array A, have pointer variable P, and here we have I and J they are both integer variables. And again, we make P point to A0. And we can write down these two statements here. The first statement is that we use I as the index of A. And we can write down I plus plus. We have the postfix increment. And if you still remember, for the postfix increment, the increment will happen after we finish the current statement. So that is why to understand this statement, we can understand this statement in this way. I put it in the comment. So what this statement helps us to do is to first, we assign the value j to ai, because I haven't been incremented yet. So after we update the value of ai, then we finish this statement, then we increment I. So now if we code ai after this statement, we move to the next element in the A array because we increment I by 1. So this is how we can do using the array index. So the final statement here, the statement P plus plus and J, and please don't freak out when you see these statements. It's not very complicated, although it might be complicated at the first sight. So to understand it, what we want to know is that this is the postfix increment, right? So this will happen after we finish this statement first. So we can just pretend it doesn't exist at the beginning. So what happened is that we just assign j to where p is pointing to. So p is pointing to A0. So it's actually these two statements did the same thing. So we again assign j to where p is pointing to, and after that we increment p. So we then evaluate p plus plus. So p will then point to the next element in the array A, because p is originally pointed to the A0. So you can see how we can combine the indirection operator and the postfix increment to use one line, using one line to complete both things. We assign the value to it and then increment p. So here are a series of possible combinations between indirection operator and the increment operator. And I will explain them one by one and show you what is the meaning of each expression. So the first expression is what we saw in the previous slide. So when we write down this expression, the meaning is that we will get the value of where p is pointing to before increment, and then after we get the value, we then increment p later. So what happened for this expression, let's assume that p is pointing to the array here. So originally, we just get the value p is pointing to, so we will get the value 2, and then we increment p itself, so p will move from here to the next element. So let's check out the next expression. So the next expression, we have a parenthesis here. So the only difference between the first one and the second one is that we have the parenthesis. However, this parenthesis makes huge difference for the second expression. Because if we add the parenthesis, that means that we need to treat this all together. So what the meaning of the second expression is that we get the value of the star p before increment. That is the same with the first one. However, what we increment is not p itself, it's the star p altogether. So you can see if we write down this expression, we will increment the value stored inside the object p point 2 from 2 to 3. So this is the effect of the second expression. So let's check out the third possible combination. So that is, we, instead of using postfix increment, we use prefix increment. So that is why we put plus plus in front of p, that is the prefix increment. And for this expression, these two things are the same. No matter you add the parentheses or not, these two expressions have the same meanings. So the meaning of this expression is we will increment p itself first. So if we increment p itself, we just move where p is pointing to on the array, right? So we need to move p from here to here because p originally pointed to the element of 2. So it will move from here to here, and then we get the value of star p after we move p. So because this interaction operator is applied to this plus t altogether, so what we will get in return if we use this expression will be 4, will be the element p is pointing right now. So what this expression help us to do is to first move where p is pointing to first, and then get the value of the elements p is pointing to right now. So let's check out the final one. So the final expressions look like this. So you can see there is these expressions are pretty similar, but their effects is not the same. It's quite different, right? So it means that when you write down this kind of, I would say, concise expression, it is very important that you know what you are doing. If you don't know, your code will just produce the unexpected result. Okay, so let's go back to the final expression here. The final expression is that we just change the order of the interaction operator and increment operator. So this expression can be seen as this one. So the thing inside the parentheses will be evaluated first, right? So what this expression will do is that first we will get the value where p is pointing to. So the value p is pointing to is 2, right? And then we just increment star p. So because this increment operator is applied to star p, so we will just increment the object where p is pointing to. So that is why p is pointing to 2. And if we increment 2, it will make 2 become 3. So this is the return value we can get, that is 3. And the element of the array p is pointing to will also be changed from 2 to 3. Okay, so this 4 expression is a bit complicated, but if you, I will encourage you to try to understand it by yourself if you still feel it's very confusing. And if you can really understand all the expressions, I believe you will have no problem with other kind of pointers and other kind of combination between interaction operator and the other operators. Yeah, so that is something I would recommend you to do. But if you just feel this expression is too confusing and difficult for you, then I will say just don't use this concise expression. We can always split one statement into different statements. So as long as the statement is understandable for you, you should choose that kind of statement. So actually we can just break this expression into 2 statements, right? I can use 2 lines to produce these to conduct these two actions. I don't need to really combine them all together. But if you want to kind of using this concise expression and trying to show off that you are really an expert in C, this is something you might want to learn. Okay. So, but among them, one of the combination is the most common. That is this one star P++, and this is useful in loop. So if you're gonna choose one to remember, you just choose the first one, because if we write down loop to use a pointer variable to traverse in the array, this is really handy. So yeah, I will recommend you to use this in your code. And in this example, we're just trying to revise the original full version into the while loop version. And here is more example of how we can use this combination in the example we saw in the previous course. For example, we talk about how to implement stack in C, right? So the original version of the stack. So this is a part of the code for the stack. And when we talk about stack, we say that we need to have another separate integer variable top to indicate where is the top in the stack, right? Because we need to know where is the top so that we know where to push or pop the information from. However, we can actually replace top by a pointer variable top PTR. So we can, instead of have another integer variable top, we can have the integer pointer variable, and this variable point to the content array directly. So we can directly point to the content array, and we can get the value inside the content array by this top PTR pointer variable. And here, if we use this pointer variable version, we need to change some code. For example, in the push function, instead of writing this statement, we can write the statement like this. And in the pop function, instead of writing this statement content and the minus decrement and top, we can write down the statement like this. And actually, we already introduced all this combination in this slide here. So what I want to do is to invite you to take some time to think about why in this version we need to modify these two statements in this way. So first, you need to understand the meaning of these two statements, right? So you can just remember the statement here and then go back to here to see what is the, so this statement is actually fits the format of this expression. So what this means is that I will get where top PTRs point to, and then I will increment top PTR itself. So you will point to the next elements in the content array. And then you can check out the statement inside the pop function and try to think about why we modified this content, the original statement, into this. Okay, so I will leave this for you guys, and you can think about it during the break. So let's have a short break. So please come back here after 5 minutes.